Hey there, everyone. My name is Ryan Schul. Welcome to my channel. It's all about data, analytics, predictive analytics, advanced analytics, and things such as this, machine learning, data science, artificial intelligence, all this fun stuff. So in the project today, I want to take a look at how we can reduce grocery food waste and do better forecasting of demand, right? And try to create some type of smart ordering system. Okay, so we're gonna accomplish a few different tasks here. It's multifaceted, it's very interesting. So let's get into it. So we can easily predict demand for grocery sales and then use that to forecast into the future what the demand is going to be, right? And then order the appropriate number of items based historically on the frequencies of sales that have occurred in the past, right? So we're more concerned about the shelf life of certain items, especially things that are perishable, fruits and vegetables, things like bread, right, that can become moldy if it stays on the grocery store shelf too long. But the other things like if your store sells laundry detergent or canned food items, those are lesser concern, right? Those don't really become perishable. So yeah, let's get into it. So I created a few algorithms here. Let me click this Control Enter to run the cell, and I'll take you through what I'm doing here. So I'm going to create some synthetic data. Now this should be pretty realistic and pretty accurate. I looked online for some samples of data. I didn't find a whole lot. I found one guy that was willing to sell me grocery store data, all kinds of stuff. I mean, it's pretty comprehensive, way more than what I'm looking for. And I think it was a lot, like $1,000 or something. I don't want to pay for the data. I want to make this free, open source, so anybody can use it and learn from it. So I'm just creating my own. But again, this should be pretty realistic based on what I think grocery store items should be. If you think it's something a little bit different, if you think tomatoes should be $2.79, then just go ahead and change that, right? I think these are okay based on the neighborhood where I live. So yeah, so we're going to set 1,000 days for our time series analysis, right? And we are going to start on January 1st, 2025. Today is actually October 12th, 2025. We're going to go back in time a little bit to capture some historical data and then make forecasts into the future. So all of these things are changeable, right? These are just parameters and inputs. You can set this to whatever you want. The number of days that you look at can be 500. It could be 5,000, right? I think 1,000 is good. For some of these models, you do need enough data to feed into the model so it can make predictions into the future, right? If you feed in number of days 100, there's a good chance that some of these models just don't have enough historical data to go ahead and do validation and understand what's happened in the past and make predictions into the future, right? So you do have to pick, enough deep enough data set going back in time to make the model understand what's going on and to help it and to encourage it to make accurate forecasts into the future, right? If you set this to 10 days, the model's not going to know what's going on. It doesn't have enough data to learn from. So we're going to create a couple little loops here. For I equals D and enumerate, we're enumerating through dates. D is the date, I is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, things like this, right? So we're just enumerating through different items and appending these into a list right here called rows. Okay, Control C, Control F. All my rows go down here, rows.append. If you watch my other videos, I do this all the time. This is pretty common for myself. And I think this is pretty much standard practice. Other people might have their own sort of like temperaments or personality related to how they do their coding. And I understand there's many ways to skin this kind of cat, right? There's always different means to the same end. I think this is simple, intuitive, and I think it makes a lot of sense. If you have another method that you like better, go for it. Go ahead and use that. So I'm going to create a couple UDFs over here, fit baseline. So this user-defined function is going to help me to understand all the SKUs. So the SKUs come from over here, the whole catalog, right? So these are all the different items that we're looking at. And again, I don't have actual grocery data. I'm not going to pay $1,000 for the data. I'm going to create synthetic but realistic data. So that's what this does. It goes through all the SKUs and goes through all of the rows for each SKU, and it goes ahead and does some basic demand predictions, right? Looking at standard deviation. Standard deviation is the shift around the mean so we can understand the mean. The mean comes from right here, okay? And we can understand the deviation from the mean. That's the standard deviation. And are we skewing to the right? Are we skewing to the left? Things like that. That's what that UDF is for. And if you don't understand all the terminology here, that's totally fine. I created code to be pretty straightforward and pretty simple. So you can just copy and paste this into your own Jupyter notebook. I will save all the code for you and upload the code source when I upload the file. So I'll actually save it right now. This is tested and validated, so that's fine. So go ahead and copy paste the code. It's going to run straight out of the box. You just have to drop it into the cell here and it's going to run. So what's the next step here? So we do have to create training and testing data sets. I'm not going to go into a deep dive here because this video is already pretty long as is. I put in a lot of different like cells into this notebook to try to illustrate multiple different points. I'm not going to go too much into it, but you do have to have a testing data set and a training data set. So the testing is always going to be bigger by default. I believe it is 70%. You can change it to 75, 80%. The training, the training is the bigger one, right? The training is the bigger. It'll be probably 70 to 80%. The testing is going to be smaller, probably 30 to 20%, something like that. And you can think of it like this. The training is if you were in school, whether it's grammar school or high school or college, the training is reading the textbook, going to class, taking notes, studying, right? The testing is when you go take the test, how well do you perform? Are you getting 100s on your test? Are you getting 90s, 80s, 70s, hopefully not less than 70s, but that's the difference here. We have the training set that's always going to be larger, right? You feed in the data, then you do the test, and you don't feed in all the data because the model would simply memorize everything that goes into this. You want the model to learn the data and to make abstract predictions into the future of what's going to happen next. And then it compares the prediction that the model made to the actual data to see what the difference is. And that tells you how well your model is learning. So we cover all the training tests and the data set for that specific reason. And in this case here, I am fitting this model with the training data. So if you look closely, the training data comes from here, right? I just told you about the training DF and the testing DF, that's short for data frame. So for each SKU, we're actually using simple aggregation from the training window. The demand for the SKU by the day of week, DOW, is not like some kind of finance Dow industrial. It's short for day of week. And the uplift is ratio of demand on a promotion versus non-promotion days. Okay, so there is more of a driver if items are being promoted or there's some discount. Probably people are going to be motivated to buy more of those items. If it's just normal, standard, regular price, I would expect sales to be a little bit under sales, what sales would have been if there was a promotion. Okay, and we look at the standard deviation of residuals. Like I mentioned before, you get the mean, which is the average, and you look at the standard deviation to see, is it skewed to the left or to the right? All right, so on to the next cell here. So let me run this. So we want to understand all the SKUs in each category in the history, right, that we're using for the training and in the model that we're feeding into the model based on the history, okay? So again, we have 25. The SKUs come from this list over here. This is certainly not comprehensive for any grocery store. I just came up with a list of 25 items that are pretty common that you would see in basically any grocery store. But of course, this is not comprehensive. The full grocery store list would be way bigger than 25 items, unless you are in some kind of weird grocery store that specializes on some niche product or something like that. That's not what this analysis is for. It's for like a common normal grocery store. So going through all the code down here, we were doing some simulations, right? That's how we're trying to understand. In the past, we know what the sales were, right? We're trying to make predictions into the future and understand what's going to happen next. That is the whole point of this exercise, right? So I'm trying to simulate into the future based on the mean, based on standard deviation of historicals, right? And even looking at some kind of outliers too. So this is sigma times 2. So we can look at the mean, which is the average sales. One standard deviation would be one move away from that. 2 would be a bigger move, right? So 2, I think, covers 90, 90 or 95% of the possible outcomes. Let me look over here pretty quick. I don't memorize these things. I just understand the basic concepts and then try to apply that. But it would take standard curve, take way too much brain power to memorize all these things. And I'd rather use my brain to learn and to figure out complex problems, okay, rather than memorize things, because then I wouldn't have any capacity left for learning. So 68% of the data is one standard deviation, 95% is two standard deviations, and three standard deviations covers 99.7% of all the data. Okay, so I think two moves away from the mean is sufficient here for what we're looking at. And what we're going to focus on is the quantity of items sold, the sales, overall revenue, cost of goods sold, and the overall need. I'll show you how this works in just a minute. And we're going to consider the date, the sales units, the revenue, and any potential stockouts. So a stockout could occur if you have items on the shelf that are all sold out. Then, I mean, it's kind of good because you sold all your items, but the bad part of it is, and there's always a good and a bad for everything, right? The bad part is now you could potentially be selling more items, but the shelf is barren, right? So you can't sell anything. So you're missing an opportunity. This is an opportunity cost that has slipped away from you, okay? So you want to try to manage your inventory so it's pretty much stocked on the shelves. When supplies are running out or dwindling, right, we'll create a reorder point and restock the shelves. So you don't want the stuff sitting around for too long, and you don't want to sell out and there's nothing left, right? You want to get that Goldilocks spot right in between. So we have 25 SKUs in the catalog, in the history, and in the model. So everything came through fine. This is what the data frame looks like right now. We have the dates to SKU. These are the different items in the grocery store, sales units, okay, demand, true. Usually these are going to match up, okay? The only time this is not going to match is if there's stockouts, right? So in this match, no stockouts, no stockouts, no stockouts, no stockouts, no stockouts. So all these sales units and demand equals true, or demand true is the same because there's no stockouts, right? So that's what we want to. That's a goal here. We want to prevent stockouts, and we want to prevent items from sitting on the shelf for days and weeks and months, and it just drags on, right? So I'm also looking at revenue and COGS. So that is important. Revenue minus COGS is the it's like basically not your profit, but your gross profit, right? So revenue minus COGS, cost of goods sold, is your gross profit. You'll still have other costs, like you have to pay the staff to manage the grocery store. You have to pay the electric bill to keep the lights on, and the freezer for the ice cream, and the refrigeration for all the veggies, right? So there's a cost of doing business that gives you your gross profit, but then you have to subtract out all the operating expenses and things like this. And then eventually taxes, you have to pay taxes on your gains, then you'll have the net income after that, okay? So it's more like finance and accounting. We're not gonna get too much into that, but I wanna focus on this stockout, right? And prevent stockouts to the greatest extent possible, and waste units. So waste is if something becomes perishable, or something that's perishable becomes rotten and we have to throw it out, then it's wasted opportunity for the store. We're losing money, right? So that is the goal here. We're trying to prevent stockouts and trying to prevent waste. So moving on, we can look for waste adjusted profit. This is basically revenues minus COGS sold minus waste cost, right? So again, I told you there's a cost of doing business, right? That could be part of the COGS. But in this case, I'm actually subtracting out the waste cost to try to understand that component better. But COGS is basically the cost of goods sold, right? So COGS is what you're paying, like what you're paying for the raw materials, and then you have a markup on something, right? So let's say a very simple case could be a can of beer costs you as the grocery store owner $2, and you sell it for $4. The markup on alcohol is pretty steep, so that's a pretty realistic scenario right there. So if you pay $2, that's your COGS. If you sell for $4, that's your revenue. You take your revenue minus COGS, that's your gross income right there, or gross profit. That is $2 for every beer can sold. And beer isn't really going to go to waste, but if you have perishable items, bread, cheese, milk, veggies, fruit, things like that. You could have a waste cost associated with those. So I want to understand the overall sales units, waste units, and the cost of goods sold divided by the sales units. Okay, that's what we're getting the waste units here. So again, we're going to look at the days that we are operating in this simulation. I call this sim because it's a simulation here. All the rows, the service level, and the share of days sales equal demand. Okay, so let me run this, Control Enter. Okay, and by the way, if you guys see any mistake with the code or logic is somehow incongruent, or I missed something or did the calculation wrong, please let me know. I don't think so. I tested this pretty thoroughly. I think everything is right, but I could make a mistake. I'm certainly not perfect. No human being is perfect, right? So if you see a mistake, let me know. I think this is pretty much where it needs to be. So down here we see the SKU. These are all items, and we have all 25. So this is comprehensive. It covers everything. We have the demand and sales, any potential stockouts. So that's, again, the shelf is barren, and we still have sales. We could have had sales, right? But there's nothing left to sell. So we're missing an opportunity. This is an opportunity cost that is going unanswered, right? So we have to try to understand this right here. And waste, this is ground beef. So this ground beef went stale or became rotten somehow, and we had to throw that out, and that cost 24 bucks, right? So all of that is going to impact the revenue and the COGS and gross profit, right? So these are the things that we have to identify and try to manage. So most of these are fine. Stockouts is 0, waste is 0, but there is an issue with the salad mix and with this one down here, ground beef. Waste adjusted profit over here, service level percent, and the waste rate right here. It's pretty low. It's measurable, but it's probably de minimis. It's only 5%. So, note to self, we'll try to prevent that from happening next time. We'll order less beef and potentially have a stock out. Hopefully not. If we're ordering too little, then we can learn from our mistakes and order a little bit more, but there should be a sweet spot in between. If we are losing 24 items, this is number of items that we had to throw out or servings, whatever you want to call it. This could be number of servings that were basically stockouts, right? So we have to focus on these two items right here and manage that a little bit more efficiently. Everything else looks like it's on the up and up. So let me create a couple charts. I always say a chart is a picture's worth 1,000 words, and a chart is a visual rendering of the data right here. So here we're looking at waste by SKU. So we saw above it's 27 units, or 24. This is 24. And we see some of the metrics behind it. I like these Plotly charts because it shows you these tooltips or pop-ups. I think they're called two different things, but it means the same thing. So you can put the mouse over it. All these are 0 except for beef. We can see we had 24 servings of beef that were wasted. The demand was 47,819. Sales was 56,622. Stockout is 0, so we're managing that. Stockout fine, but we ordered a little too much beef and some of it went to waste. The overall revenue was 273K, and the COGS is 157, right? So we spent 157,000, sold the beef for 273, and in between is the gross profit, right? So going down here, we can look at waste adjusted profit by SKU. So here's all the profits by the SKU. So rice has the biggest profit. And again, we're defining this like basically revenue minus COGS, right? And you can see this is in descending order. I put all this descending. It comes from here. SKU sort value is waste adjusted profit, and ascending equals false. So this is descending. If I change this to true, it would just flip the chart the other way around, right? I like this view a little bit better. That's my personal preference. Maybe you like the other way. It's really up to you. These things are pretty flexible, right? So you can change it to do whatever you need. So here in the next chart, we're looking at the top 10 waste days, okay, over the course of time. And we're going back to, we're going, now we're looking into the future, top 10 waste days. So this is July 2025. We had some waste here, only 7 units, not huge, but it was something. Over here, later in July, we had waste of 4 units, pretty small, kind of trivial, 4 again. And over here, we had 8. So just something to be aware of. This is not going to put us out of business as a grocery store, but if we can manage these waste days and get these down to 0, it just behooves us, behooves the business to do that. The profits will get a nice little bump from that, right? And all of this analysis and all these charts are just to get greater insight into the data and how it's speaking to us, what kind of story it's telling us, and just so we can make more intelligent, more informed decisions. That's the whole point of this whole exercise, right? So let's go ahead and dive a little bit deeper and add in a couple more features. I want to look at some drivers here that control the sale of items in our grocery store. So it could be weather, temperature, precipitation, holidays could be a driver, promotion depth, price changes, heterogeneous SKUs, long life versus short life. What else? Operations, supplier lead times. How long does it take between the time we make a call to the vendor or the broker that's selling the item and they can actually deliver it? That's something that we have to consider, right? If it's same day, it's probably not a major concern. If it's going to take several days or over a week or maybe 2 weeks, then that's something that we really have to manage proactively and stay ahead of the curve, right? And any kind of markdown logic, sales, and we want to stimulate demand and get some items off the shelf. Maybe new items are coming in or a new brand is coming in to replace an older brand, right? So we can go ahead and create some markdowns to try to stimulate sales on certain items and get those off the shelf. Okay, so now I want to look at a couple different probabilities, probability 50, P80, and P90. So when we look at these probabilities, we're going to consider a couple things. DOW is the day of the week. Is this a weekday or a weekend? It makes a difference, right? I don't think too many people are going shopping Monday through Friday. They're busy with work, their exercise routine or whatever. They got a lot of stuff going on. I think more people are doing their shopping Saturday and Sunday. I didn't even do the analysis here, but in other data sets, that's what I've noticed. So day of week does matter. Maybe it's not material. Maybe it's somewhat insignificant, but the day of the week definitely does have an impact on the sales that you're making. I want to look at a lag, and this is 1 day back, and a lag 7. This is 7 days looking back in time, and this is going to be a moving average of 7 days. I'm going to use all of these metrics to create a model to feed into my model. I'm using a gradient boosting model. Here are the independent features right here. Okay, X is independent, Y is dependent. So the Y is dependent on the independent. This can be anything, but the demand is going to be driven by these features over here. Okay, so the day of the week will control the demand. The demand will not control the day of the week. That doesn't make any sense, right? Promotions can control the demand, right? Increase the price and people buy less. That's not promotion. It's like an anti-promotion or something. But if you decrease the price, it's going to stimulate demand, right? So that's what we're looking at. The demand is the target variable or the predicted variable. So I go down here, I run this. I have to create one more UDF to do a forecast into the future. There's one more thing I want to show you too. The gradient boosting regressor right here is the model that we're using. So I tried a gradient boosting, like a light gradient boosting, or I tried a couple, and it didn't work very well. It didn't produce great outcomes because the training data really needed to be more, had to have more features and be more robust and just more data. This data set is actually kind of small. It's kind of trivial, right? So I just found that this particular model performed better than some other models. But there's a whole bunch of models that you can consider using for this exercise. I think this one performs reasonably well. Okay, so we have three different instances where we're running the model. So here is with, let me see, alpha at 0.50. So this is going to be the most likely scenario. We are going to look at alpha 0.80, right, and get the GBM 80, and the GBM 90 comes from here, alpha 0.90. And basically the way to interpret this is at 0.50, this is the most likely outcome. And it can deviate a little bit more, a little bit less. When we look at alpha 0.8, it's going to be a higher number, and most likely the number of sales that we see is going to be under this 0.8 most of the time, right? So the number is going to be a little higher. I'm also looking at alpha 0.9, so this boosts the sales number even higher, right? So the average sales that we would expect is 0.50, but we get to have a lot of people, for whatever reason, coming into store and buying 30% more and driving that 0.5 up to 0.8. So we're selling more inventory, 30% more than we normally do. And in some cases, it could be 40% more. So I'm looking at the 40% scenario here. And of course, I'm fitting every model down here. This is the 50, the 80, and the 90. And then making this as the baseline for my forecasts into the future. Okay, so that's a lot of stuff. I know. I've been doing this for like 13 years. When I started out, I was like, say, what? Like, what you talking about, brother? But hopefully that makes sense. If not, Google it. Google is a skill. ChatGPT is a skill. So go ahead and take a look at these things. If you don't understand, I think you're going to learn a ton. Hopefully you understand most of this stuff, and this teaching lesson could be more of an exercise to fill in gaps. Maybe you understand most of this stuff and you say, oh yeah, that makes sense. And you can just run through this, okay? But that's the takeaway there. So I want to create a data frame with the SKU category. These are all the items that we're selling, the day of the week, any kind of promotions. And is there a lag 1, lag 7, or a moving average that has any impact on these sales, okay? So when I run it, I get this result down here. Let me expand this, and we can see the average. These are the items we're selling on the date, and the entire IQR is going to be 116. On this date is 114, back to 116. So you can see it stays within a certain margin here. The Q80 is going to be a little bit higher, right? Because we expect potentially higher sales, right? But we want to prevent these stockouts, so we want to know how many items would sell under each of these potential scenarios, right? Q90 is going to be even higher. So here we sold 129 apples. Over here we sold 116. So the average is 116. In some cases, we can sell 129.6, almost 130 apples. To sell more than that, when the average is 116, like, would you really sell 150 apples on one day, right, and exceed this Q90 threshold? The quartile 90% of the time is going to be less than that. Yeah, it could happen, but probably not. So I wouldn't go ahead and order 130 apples or 150 apples or whatever for this one day. It's probably not going to happen, but in some scenarios, it potentially could. So we go scroll down here, we can see the different dates here. This is a sample of all the items in the grocery store, right? With the item, the date, the Q, 50, 80, and 90. I'm going to shrink this down a little bit to give me a little more space to work with. Okay, so I think we're in a good spot with these quartiles, with these forecasts, and these projections. I want to go ahead and understand visually what just occurred there, okay? So Control Enter to run this. I am going to loop through all the items, not all, the top 10 items in this data frame. Lost my train of thought there for a bit. And look at all the SKUs, and we're going to look at the top 10 unique items. Let me expand this so we can see historically what sales have been, and we can look. In this case, the medium is the P50, right? That's the average that we're going to sell, but it could go up higher, it could go up to P80. So I'm saying, what is the most likely scenario? It's about P50. This is equal to the median, right? So I can click on this and I can see the median or the P50, and the P80 is the upper 80 quartile. So only 20% of the time the sales will exceed that. Most of the time it won't. So we have apples, bananas, and beans, and beef, and broccoli, and all this stuff. And if you wanted to somehow see all 25, we could loop through everything. This is called slicing. We could take off the slicer and get all 25 items if that's what you need. Okay, let me expand this, and then you have everything in the whole grocery store universe. Okay, ending up with yogurt cup. I think top 10 is sufficient. I'm just trying to illustrate how this works. I don't want to see everything in the universe. I just want to see from the beginning to the top 10. So we'll get the top 10. Okay, and there we go. So I also want to take a look at these SKUs based on the date and the quartile 50 and look at everything simultaneously all at once. So again, we can do a slice over here and look at the top 10. or look at everything. Okay, this is going to give me everything. All right, so I think this is looking good. At this point, we have no slicers applied, right? So we're getting everything from the beginning to the end. We have 25 SKUs, so 25 items in the grocery store. And we can see the most likely scenario. Again, the y-axis shows us the 50% quartile, and the x shows us the date, right? So the y goes up and down, and the x goes horizontal, right? You just want to see the top 10. We can go 10, Control Enter. And these are the top 10, okay? So anyways, just a visual, just another image here, another chart to show you what's going on, and you can see the overall universe of everything, 50% quartile, and most likely sales over a period of time, okay? So one more thing I want to look at here, Control Enter to run, is the Q50, right? So the 50% quartile, the Q80 to 80% quartile. Remember, 50% is average. Every once in a while, we'll exceed average in terms of sales. It could go to 80, 90. If it exceeds 90, that would be very unusual. We'd probably see a stock out at that point. But it could happen. But most likely, what you'll see is the blue bar. So in 2 weeks, we would sell about 2,912 bananas, so on and so forth, down to coffee. And coffee in 2 weeks. Wait, did I miss something here? 2,912. An extra 163 possibly, right? But this would cover us for the 80% quartile. Down here we have rice, 471, and the smallest number of items sold is 361, okay? So that covers pretty much all the scenarios for the 25 items with the 50% and 80% quartile covered. So this is a heat map over here, Control Enter to run. Now we can see everything relative to everything else. We have the dates in the bottom. So we have September 29th, 2017, week by week view here, October 1, October 3. Oh, every 2 days. This is every 2 days. Up to October 11th, and we can tell by the I always forget the name of this thing on the right, the chart legend. I think it's called a legend. So the Q80 is telling us 80% of the time the items sold will be this. Bananas is the number one. We saw that over here too, right? Bananas is number one, and apples is number two. Go over here, apples is number two. 161. Bananas is a little bit higher, 256. And then earlier in the year, it was 123 and 207 for bananas. But you can see, like, the more yellow the item, the higher the number, the darker. Like if you get down here to dark blue or navy blue, these would be smaller numbers. So here's 30, right? Here's 37, 37. And over here we see 214 and 208, right? So that shows you comprehensively all the sales for all the items over a period of time. This is 2 weeks, right? So we're getting close to the end. Just hang with me for just a little bit longer. So I want to go ahead and understand the lead time demand and try to understand the reorder point. Like I alluded to a little while ago, like 10 or 15 minutes ago, at some point we're going to have to reorder this inventory, right, for new items as the shelves are being cleared out, right? So how do we determine at which point do we do the reorder, right? And we don't want to just try to guess and say, well, maybe I need 200 apples, maybe it's 100, maybe it's 500. You want to be a little bit more scientific about it and a little bit more like fine-tuned, right? So we want to try to understand historically what the sales have been, and we did the forecast into the future. You saw we did that regression model, right? But at what point should we start to create new orders for each one of these items? So that's what I want to look at right here. So we have the future sales, right? That today lead time. This is how much time it's going to take for the delivery truck to bring the items over. Again, it could be same day, day of. That would be a little bit unusual, and more expensive. But maybe you have a certain contract with a vendor that's right down the street from you. Maybe it's possible. There's probably some lead time, could be days, maybe even weeks, that you have to be cognizant of. The shelf life of the item, right? Like how long is it going to be around before it spoils or becomes rotten? quantile column, right? We looked at the P50, 80, and 90, and then any kind of inventory batches. So this all ties together, right? So it's highly integrated. This is why we're calculating the Q50, Q80, Q90, because again, we have to understand what is most likely to happen is right here. 80% of the time, it's going to be a certain number or lower. 90% of the time, it's going to be a certain number or lower. But 10% of the time, sales could exceed this threshold, and it's going to create a stock out, right? So that's what we tried to manage. I said this a couple times at least. We want to be aware of stockouts and try to prevent that from happening. We want to be aware of waste and what else? Just be aware of waste and food going rotten, and we want to prevent that from happening, right? So when I go ahead and run this, Control Enter to run it for all the SKUs, all the SKs and SK units, we want to know the lead time, the shelf life, the service, and again, the time for delivery, right? Like how long is it going to take the truck to deliver the items that we need? We created a list over here. The list is coming from this, a square bracket. This is pretty standard way of doing all this stuff. If you watch my other videos, I do this all the time. So you do the analytics right here, do the append. We have the item in the grocery store today, alpha, quantile used, so on and so forth. This is repurchase, right? Reorder point, and order up to this number of units, reorder trigger, and any kind of recommended order. Okay, so I'm going to go ahead and run this, Control Enter to run. And we have the reorder point right here. So we can see the SKU, this is the item, right? For the day today, the alpha quantile used, we're looking at 80. So 80% of the time, this is going to be correct. Maybe 20% of the time, it won't be. I think 80 is fine in this scenario. I don't think there's anything to worry about. Lead time is delivery time. Shelf life is here. ROP is reorder points, okay, and order up to this number of items. So if we get to 198 units, we have to order potatoes, right? Because it's going to take 2 days to deliver the potatoes, and we want to make sure we have enough potatoes on the shelf so we can continue selling potatoes. If we sell out and the shelf is barren for potatoes, that's not a good look for the store, right? So we want to stay on top of this stuff. This is a reorder point. When we get to 198, we submit the order, and we'll order 1,474 items, okay? And let's see, recommended order is basically this over here, just without the decimal place precision, okay? That's all it is. So because you can't actually order 1,474.051221 potatoes, nobody's going to handle that transaction. You're going to order 1,474 potatoes. And in all honesty, maybe you have to round that up or round that down. I'm not sure, because I don't manage a grocery store. Can you actually order 1,474 potatoes, or is the farmer or whatever, the broker that handles the transaction, are they going to require 1,500 because they want a round number? Probably, but I don't know. But this is the optimal number right here. So we're doing mathematical optimization here. Maybe the seller is going to say you have to get 1,500 or take a hike. So that's that. I have all these columns I think are pretty intuitive. I have just a couple notes down here. Reorder point is the inventory level which triggers a new order so you won't have an outage. And the order up to is you don't buy more than that, but you buy up to this amount. This would be the optimized number of items to buy. For ground beef, we can see it's 108. Oh, when we get to 108, when we get down to 108, we order 160, okay? So take a look at that. And again, like if this totally doesn't make sense to you, that's fine. I've been in this for a very long time, so I know how this stuff works. But if it does make sense, just Google it, ChatGPT, read a couple of books. I've read at this point probably over 1,000 books since I finished college, just to get to where I am today. And still I'm learning new things every single day, right? The day we stop learning is the day we die, literally. So I think every day that you're still around, I think you should be learning new things, right? So just to wrap this up, in conclusion, I think a good future state might include things like weather, temperature, seasonal patterns, rain, probability, and intensity. So I didn't address these because this case study is already pretty long. I think I actually had something above this. Let me look for this. Now it's one of one. Let me pause for just a moment because I had some notes over here. I don't want to duplicate. No, it's fine. Yeah, that's fine. So this is what I was looking at. If I go back, why is that doing it? Okay. So some things that can drive sales in a grocery store is temperature and precipitation, long shelf life, supplier lead time, right? How long it takes them to get the item to our grocery store. So those are some things that we have to be aware of. But my point is for the future state, if you want to level this up and take this up a notch, we could further analyze what kind of impact does the temperature have on sales, right? If it's really hot, maybe people aren't going to the grocery store. If it's 110 degrees, I'm probably not going outside. I'll stay at home, blast the AC, and just wait for the heat wave to pass, right? Seasonal trends and patterns, I didn't look at that. That might be worth looking at. So around the holidays, people are buying more stuff, right? Going to parties, things like that. That could definitely increase sales. I didn't adjust for that or account for that in any way, shape, or form. Calendar weekend or weekday flags. Now we are looking at day of week. I showed you Dow before, so that is being analyzed, but maybe day of week plus holidays. Like if the day of the week is on New Year's Day, Friday, and the store is closed, well, yeah, that's going to impact sales. You're not selling anything on if the store is closed. Maybe the store is open, right? And that might drive up sales because a lot of people aren't working. Maybe some essential workers are, but maybe most people would be working, and maybe sales in a grocery store would spike up for one day. That could be something that could be worthwhile to analyze. I did not look at that. And again, promotions, I kind of mentioned that before, but I didn't do like a hardcore analysis on promotions. But if you do promote different items in your grocery store over the course of a month, right? If you have different promotions, maybe meat the first week, maybe dairy the second, veggies, fruits and veggies the third, and maybe grains, bread, cereal the fourth week of the month. Maybe there's certain ways to optimize the promotions, right? Like there's many ways to run optimization analysis and look at different scenarios. I did not do that, but maybe that's worthwhile taking a look at. So food for thought. So I think I already downloaded this file. Let me check my download folder. Reduce grocery store food waste. Yep. Okay, so I got it. So I will share the code with you guys when I post the video. I'll do that a little bit later today. We're already up to 42 minutes, so this one has dragged on for quite a bit, and I tried to hustle through it. Otherwise, this is going to take the entire afternoon, and I don't want to subject you to that. Okay. So try to go through pretty quick, but all the notes are in here. All the code is in here. You can drop it into your Jupyter notebook, run it as is. Should work fine. If anything does not work, probably you don't have a library installed. So make sure you do a pip install for these and should be good to go. If it works for me, it's going to work for you. That's it, guys. I'm going to wrap it up right now, and I'll see you in the next one. Goodbye for now. Thanks.